All right, so this is the last few problems on the paychecks and interest. So I have a problem that is an example of each type of interest: simple, compounded, and continuously compounded interest. So for the first one, it says David puts $5,500 in an account that earns 4.8% simple annual interest. How much money will David have in his account after 5 years? So a few things about this problem. The fact that it's simple interest tells me that we're going to use this equation. The fact that it's annual interest tells me that it is yearly or once per year. So if we want to know after 5 years, it will be calculated one time each year for 5 years. So that means our T equals 5. Our rate is this percentage, but we can't use it like that. We have to change it to a decimal by dividing by 100. So R is 0.048, and the P principal is the beginning or starting amount of money. So I'm going to plug my P, R, and T into the equation. My rate is 0.048, and my time is 5. So if I do that really quick, 0.048 times 5 gives me 0.24. So in other words, that would be 5,500 times 1.24. And that gives me $6,820. So this is my answer because it says how much money will he have in his account. If this had asked me if I just wanted to know the interest, which I didn't, but if I had just wanted to know the interest only, then I would take the account balance and subtract how much money he initially put in that account. And I would find that he had earned $1,320 if I just cared about the interest. There are questions on the test that only want to know about interest, but this is our answer right here to the question that was asked. So question number 5 says Elizabeth puts $1,000 into an account that earns 3.7% interest compounded quarterly. How much money will be in the account after 5 years? Okay, so compounded quarterly, so compounded interest. My formula for that is balance equals principal times 1 plus R over N times N to the T power, N being the number of times per time period that interest is calculated. So 3.7 is my rate, but I want to turn that into 0.037. 1,000 is definitely my principal because that's my starting amount. My time is 5 years, but it says compounded quarterly. So I need to know how many times per year. If my time period is in years, I want to know how many times per year interest is going to be calculated. Well, if it's quarterly, that's every 3 months or 4 times per year. So N equals 4. So I have P, N, R, and T. I'm ready to go. So P is 1,000. My R is 0.037. My n is 4. Out here, my n is still 4, and my t is 5. So if I start doing some of those calculations inside the parentheses, I get 1 plus 0.00925. Outside, 4 times 5 is 20, so my exponent is 20. And then I'm going to come up here, I'm going to continue on. B equals 1,000 times 1.00925 to the 20th power. To the 20th power seems like an awful lot, but we realize it's almost 1 I'm raising to the 20th power, so it's almost like doing 1 times 1 times 1 20 times. But this gives me 1.2022, and when we multiply that by 1,000, we get about $1,202.20. So the last one, this one's a little bit different. Nigeria buys a new car for $24,875. She pays 1.9% annual interest compounded continuously. How much will Nigeria pay in total if it takes her 6 years to pay off her loan? So my formula, we always want to start with the formula. So P of t is my principal as a function of time equals my starting principal, E, which is a constant, R being the percentage, annual percentage rate in this problem, and T being the number of times or the number of time periods that are going to pass. So in this case, 6 time periods. So T is 6. This is my P sub 0, my starting principal. I turn this percentage into a decimal, and that's my rate. And then E is just a constant, so that should be in your calculator. So now I'm just going to plug in numbers. So 24,875 times E to the 0.019 times 6. I'm going to put parentheses around that 6 because that wasn't, kind of looked like 0.019.6, so that's not good. So that's 2 sets of parentheses there. All right, so if I go ahead and do the multiplication out here in the exponent, I get 24,875 times e to the 0.114 power. And then I put this in my calculator and I can actually replace that t with a 6 because I know what my t equals is $27,878.70. So this is my answer to that continuously compounded interest question.